All right, this video is going to be about density. Density is kind of one of those topics that just gets thrown in the end of chapter 1 of every chem textbook ever. It really has nothing to do with the rest of the chapter. That's okay. So density is not a difficult topic. It's essentially a matter of how much material there is in a given space. So the bigger the space, the lower the density. The more material you have, the higher the density. Ideas like that. Okay, there's a really simple equation that you probably saw at some point in your life. Density equals mass over volume. I guess I will go ahead and label these things. So that's density. This is mass, which has units of grams. And this is volume, and its units kind of depend on whether you're talking about solids, liquids, or gases. Typically, the answer is either cubic centimeters, milliliters, or liters. Okay. The way this typically works is if you have a solid, the units are grams per cubic centimeter. If you have a liquid, it's grams per milliliter. And if you have a solid, it's grams per liter. Okay, a liter is equal to 1,000 milliliters. So in other words, this is 1,000 times less dense than this. If you had 1 gram per milliliter, that would be 1,000 times less dense than 1 gram per liter. Okay. And it may seem stupid to have 3 units, and I can't say I'm a huge fan of it, but it does keep the numbers for typical situations between like 0.1 and like 100, so like you get like reasonable numbers to work with. And the other thing is 1 cubic centimeter is equal to 1 milliliter. So literally these first two, even though they look very different, are actually exactly the same thing. Okay. So essentially this is a measure of how much material is in a given space. So this is related to things like buoyancy, whether or not things will float. So for example, if you had a container and you put water in it, okay, I'm sure if it was sitting in a beaker or whatever this is, it would be perfectly flat, but I'm drawing waves because water, I don't know. I know I have not mentioned atoms or chemical formulas. H2O, hopefully you're aware, is water. Water, by definition, has a density equal to 1.00 grams per milliliter. Okay, it is the definition of what a milliliter is. If you take 1 cubic centimeter of water, well, 1 cubic centimeter is a milliliter. 1 milliliter of water should have a mass of 1 gram. So by definition, this is how this works. Okay. If you threw a piece of wood into it, wood doesn't have like a super specific density. It kind of depends on what kind of wood, but presumably it would float because its density is less than 1. Okay, so this would have a density maybe like 0.8. Sorry, I forgot the 0. 0.8-ish grams per cubic centimeter. And so even though this is cubic centimeters and this is milliliters, we can directly compare them because 1 cubic centimeter is a milliliter. Okay, if you threw a piece of iron in here, its density is 7.87 grams per cubic centimeter. Okay, and because its value is significantly higher than 1, even if it's just a little bit higher, it will sink. The wood has a density lower than 1, so it will float. So density is essentially the measuring tool we use to determine whether or not things will float or sink. For comparison's sake, the air floating above all this, it kind of depends on air density, it depends on humidity, it depends on a lot of things, but a typical value is about 1.2 grams per liter. So if we're just looking at the numbers, we're like, oh, 1.2 is bigger, it should sink. Yeah, the units are off by a factor of 1,000. So this should be equal to 0.0012 grams per milliliter. I did that in my head, hopefully it's right. okay, which is significantly lower than 1, which is why if you take a straw and blow air into water, it bubbles up to the top immediately, okay, because the density is significantly lower. Okay. The density of anything is temperature dependent. And this is because typically solids, or gases actually, or liquids, I guess all of them, expand when heated. So the idea is, since the volume component will change with temperature, the density will change with temperature, which means the entire thing is temperature dependent. I will tell you that in this class we are going to ignore this, but in the real world this can sometimes make things really complicated. Okay, so let's try an example or two of the actual math here and see how density works, how a density problem would look. Okay, so essentially there's only 3 variables: density, mass, and volume. You're going to have to know 2 of the 3, and the rest of it's basically algebra. So we want to know if a sample of iron, which is element Fe on the periodic table, which we haven't even mentioned the periodic table yet. Focus. Okay. Has a mass of, I don't know, 25.0 grams. We want to know what is the volume if the density is, well, earlier we wrote it down as 7.87 grams per cubic centimeter. Okay, this is sort of a word problem, and I learned over the years that my students absolutely hate word problems, so make the light a little better here. What I'm going to ask you to do is basically, we know it's a density problem. These are the things we have to work with: D, M, and V. Let's figure out what those things are. We're not going to know all 3, but we can narrow down what we do and don't know. So the density is 7.87 grams per cubic centimeter. The mass is 25.0 grams, and the volume is what we don't know. Okay, there are 2 ways to solve this problem, and I'm going to show you the probably the most expected way first. I actually don't think it's the easier option. Okay, so try to leave this all on there. Okay, so density equals mass over volume. The most straightforward option, or sorry, the most expected option is to just do a bunch of algebra and solve for V. So I've learned over the years that my students kind of suck at algebra, so I'm going to show all my work. I want to solve for V. I need it to be not in the bottom and all by itself on one side of this equal sign. So to get it out of the bottom, whatever I do to one side, I have to do to the other side. Okay, I'm doing this because this is in the bottom and this is on the top, so they cancel out. Now on this side, I have volume times density, and I need density to go away because I need volume all by itself. This is on the top, so I'm going to divide. If I divide density by density, it goes away. So what we're left with is that volume equals mass over density. Right? Got a little messy here, but if that stuff cancels out, that's just V. And if these cancel out, it's M over D. Okay? And then we can just plug and chug. So M, since we know what it is 25.0 grams. Density is 7.87 grams per cubic centimeter. Okay? We literally just plug it in a calculator. And so 25.0 divided by 7.87, and I got 3.1766 whatever. Sig figs are not going to go away ever in our lives in this stupid class. So this is 1, 2, 3 sig figs, 1, 2, 3 sig figs. So this gets 3 sig figs. So this would be 3.17 that 7 would round up because the next number is bigger than 5, so 3.18 is the answer. Can't write a 3 apparently. And our units, the grams will cancel out with grams, and we have 1 over cubic centimeters. So in this case, it actually reduces down to just cubic centimeters, which is great because we're solving for a volume, and cubic centimeters are a volume unit. Okay. I actually don't do it like this. I visualize density as almost a, so this is the correct answer, and this is, so this is method 1. Let's go with that. Let's give it a name. Okay, there's nothing wrong with method 1. If you do it this way, that's awesome. I'm lazy, super lazy actually, so method 2 I think is less steps and less thought, so I'm gonna do it. I visualize this as a unit conversion, so 1 cubic centimeter of this stuff should be equal to 7.87 grams. And I literally just do it as a unit conversion. So I have 25 grams, this is my conversion factor, I solve. So 25.0 grams. I need grams to cancel out, so this side goes in the bottom. I didn't have to rearrange any equations. I didn't have to think about, I don't know, really anything. I just canceled the units out like I always do. And I'm doing the same math. I'm taking 25 divided by 7.87, so I should get the same answer, but my units cancel out more cleanly. There's no algebra in the middle. I think this is easier, so I recommend this, but if this makes more sense to you, do it this way. Either answer is fine. So I still get 3.18 cubic centimeters. Okay, sig fig rules still work, units still work. So we get consistent answers. I'm happy with either one. Just do whichever one makes the most sense to you. All right, thank you.